Unit 15, Part 13. So how do I get from, so I've remembered that there's a proof bit, that there is a path from the negation. If I need to get a negated conjunction, I can do so from being given the negation of one of the conjuncts. Thinking it backwards, this is actually, I'm thinking De Morgan's backwards. This is equivalent to, by De Morgan's, not P or not Q. Okay, and this is, I noticed, in the form whereby I can just add from 1, right? So it's just add De Morgan's, that's how you get that. That's in terms of P's and Q's, sentential variables, which is how we presented the proof bits. That was important that they're in sentential variables because, as I stressed then, you need to know, you need to understand it formally such that you can recognize the times when you need it. Namely, you could have a negated conjunction where the conjuncts are big and long and horrible and ugly. But amongst your premises, if you know how to look, you might have, in fact, the negation of one of those conjuncts. It's the negation of something big, long, and ugly, but if it has that form, you can bust out the proof bit. Okay, so that's what we do here. We know we need the negation of this consequent to apply modus tollens. Oh, there's a proof bit that gets me there. Right, I can get to not H-A, leaving some space here, not H-A and W-A, right? That's what I want to get, that's what I need to do the modus tollens. Think De Morgan's backwards, it's not H-A or not W-A, okay? That's that, and that's how you complete the proof. Okay, so it's De Morgan's addition, whatever number it is, – 10, 11, 12, this is 13, 14, 15, okay. Make sure you complete the annotation of the proof. So you can now do modus tollens on 6 and 12, right? MT 6 and 12, right? Because that's where it was going. That's the end of my subproof. So how did I derive GA hook not ZA? Well, I assumed GA, and I showed that ZA follows from it. So that was a conditional proof from steps 4 to 13, right? And finally, right, I knew I was going to get this by UG, I didn't know from what number. UG, it's step 14. Do notice that difference between conditional proof and UG, universal generalization. Conditional proof, you cite the entire subproof. UG, you only cite the final line of the subproof. Okay. I fumbled a bit earlier when I was quoting from 292 or 3, when I was saying, when I was referring back to the big point from Unit 14. The pages I want to quote were where you see Klenk stressing in this chapter how important it is to focus on the form of the formulas and be very cognizant of what that form is, because that's what tells you what moves to make and how. So anyway, so I wanted to stress these passages. 284, near the bottom, second paragraph after the presentation of Rule 3, she says, second and extremely important, you may use the instantiation rules only on formulas that are of quantifier form, right? So this is ending the teaching of the quantifier rules. It's just before entering into the section on constructing proofs for pure quantifier arguments. Page 24. You may use the instantiation rules only on formulas that are of quantifier form, those that begin with a quantifier and whose scope extends to the end of the sentence, right? This is really the crucial, this text is the crucial application of the lesson of Unit 14, right? You can only use these rules on formulas of quantifier form. This means that we cannot use universal instantiation on a formula such as for all x, if for all x fx, then for all x gx. Right? I'm saying it, but I need you to see it as well. You cannot use it on this. Right? You have to look at that formula. If that's the conclusion of a proof you're asked to prove, you have to say that is a conditional. I cannot use UG on this. It is a conditional. If that's the conclusion, right, you maybe want to use conditional proof because it's a conditional. But you've got to grasp it as a conditional, and you've got to grasp it as not a quantifier statement. Also, if that's a premise, that means you're in the context of a mixed proof. If that's a premise, you cannot use UG on it. Why? It's not in quantified form. It's a conditional. I know you're bored of hearing me say this, but you've got to actually have the equivalent thought when you're in an exam, faced with when it matters, if you know it or not. Right. So we couldn't use UI on. Okay, read the rest of that, and she gives a few more examples of the same thing, and I think 287. Did I? Yeah, page 287. Another stress again. So just around here, I'm going to read from 287. Not all proofs are as simple as this one she just did. In proofs that have, so this is stressing how important it is to grasp that negations are not in quantifier form. In proofs that have negated quantifier statements as premises or conclusions, you will need to add a few more steps than just instantiation rules, truth functional reasoning, and then generalization rules. You have to add a few more steps. As emphasized earlier, you cannot use the 4 quantifier rules on negated statements. That's referring back to 284. What you must do is use QN or CQN to go from the negated statement to its unnegated equivalent quantifier formula. To brush up on your memory, these rules are stated below. If you have not already learned them, memorize them. And so this is what she lists, the QN and the CQN rules. That'll be Ilham, mate. You can let her in. Okay, that's page 287. That leads into this very important page 288. Okay, 288 gives you, in this summary form here, this statement, the strategy which is appropriate for pure quantifier statements. Okay, possibly, so first you do possibly QN or CQN, right?
What are you talking about?
Sentential rules, and then instantiation rules, sentential rules to get instances, generalization rules, and then maybe you have to do QN or CQN at the end. By the way, in practice, as we saw in the one we just did, right, the first and the last steps are kind of the first things you do, right? So if you see that your premises are negations, QN, CQN. If you see that your conclusion is a negation, then QN or CQN working backwards. Right, we didn't do it there, sorry. We didn't do any CQNs there, but if a conclusion is a negation, right, on the second last line, right, you've got lots of space. Watch out, guys, watch out. On the second last line, you write the equivalent formula, and that's now the conclusion you were aiming at, right? So the first and last lines are kind of the first things you do, right? And then you've got all your formulas in quantifier form, and then it reduces to, like we have here, instantiations, truth functional reasoning. That means, all these old rules, these ones. Addition, modus ponens, the modus ponens, the disjunctive syllogisms, the De Morgans, the sentential rules, right? And the replacement rules. All the rules on the inside cover. Unit 7 and Unit 8 rules. Those are the sentential rules to get instances. Okay, so now we're going to do a mixed one, but an important point of strategy is, okay, if you do a lot of exercises from Unit 2, as you should, they are the exercises for pure quantifier problems. When you do that, and when you get used to doing that, you will get in the habit of instantiating, you will get in the habit of, whenever you see a quantifier formula, you'll be in the habit of just, okay, now instantiate, right? Which is fine, so long as everything is a quantified, so long as the premises and conclusion are in quantified form. But the habits of instantiating from quantified formulas, or seeing a conclusion in quantified form and thinking you're going to use what, EG or UG to get it, you have to can lead you astray. They will lead you astray in some of the mixed ones, right? So you have to beware of these habits, and sometimes you don't want to follow them, right? So for example, just to give you a sense of what I'm talking about, yeah, okay. Consider this. Existent X, this is a quick one, not G, sorry, existent X, not GX, right? Existent X, existent X, not GX, existent X, AX and VX, hook, Rolex, VX, and try to derive not that does not exist an X such that AX and BX. Okay? Look at this. You'll look at the first premise and you'll think to yourself, oh, this is in quantified form. Boom. What use am I going to make of that formula? I'm just going to instantiate from it. Right? So right away I'm going to write not GA. EI from 1. Okay? See, that will be the kind of habit you're into, having solved a bunch of pure quantified problems. But here, you have to not do that. Here, the way to solve this proof, this is a mixed problem, the way to solve this proof is keep this in quantified form and manipulate it. That is, in this case, QN it. Quantify negation equivalence. It's not a categorical. By the way, I should say, this is a perfectly fine existential instantiation, by the way. Don't be freaked out by the fact you've got a negation. What does this say? It says, there exists an X such that X is not G. Right? Something is not G, that's all it says. And this says that the individual A is not G. So that is a perfectly legitimate existential instantiation. I'm just pointing that out because that's a perfectly fine legal formula. You can instantiate to it. But here, see that you don't want to do that, right? You want rather to, right? So what's the conclusion? The conclusion here is the negation of the antecedent. I'd like to do a modus tollens to this, right? Because this is a conditional. Notice that premise 2 is something crucial. Premise 2 is not a quantified statement. It is a conditional. This is a hook. That's the major operator, right? And the conclusion I want is actually, right? Again, your habit will tell you to transform this by, in this case, CQN to get it in quantified form. Don't do that here, right? Because this is in fact the negation of this. It's the negation of the antecedent. So I might get this by modus tollens, right? Not by CQN, but rather by modus tollens. What do I need? I need the negation of the consequent, not for all x, gx, and it turns out that that is exactly the result of QNing by 1, right? I've turned something in quantified form. To solve this one, I turn something that is in quantified form to something is not in quantified form, right? That is like against your habits for the pure ones, okay? But that's what you needed to do to solve this, right? Transform this to that by CQN because you've realized that this is a conditional and the conclusion is the negation of the antecedent of that. So you want to use truth functional reasonings to get the conclusion.